In this video, we are going to solve a system of linear equations using elimination. So elimination is one of the three strategies we can use for solving a system of equations. It's an algebraic strategy, which means it doesn't involve a graph, and elimination is used when we can easily eliminate a variable by adding the two equations together. So what I mean by this is we're going to look at the two systems below, and these are both set up in such a way that if we add the two equations together, a variable will eliminate. So notice here I have my two equations, and if I add them together, so notice here is my equal sign goes here. 6x plus 3x is 9x. Negative 1y plus 1y is 0y, which means it's really just 9x on the left-hand side. And then 5 plus 4 is 9. So essentially, if I add the left-hand sides of the equation to the right-hand sides of the equation, the y variable is completely eliminated, and I'm left with just x. This is a situation where elimination is a great strategy to use because I can eliminate a variable by simply adding the two equations together. Now from here, if I look at this second system, if I were to add these two equations together, 4x plus negative 4x is 0x, 16y plus negative 8y is 8y, and 36 plus 12 is 48. So on this particular system, if I add the left-hand sides of the equation together, I'm left with 8y. And if I add the right-hand sides, I'm left with just 48. And here, the x variable is eliminated. And essentially what happens when we are able to eliminate those variables is we're now left with two equations that we can actually solve for a variable value. So again, elimination is great when we can easily eliminate a variable completely when we add the two equations together. Now, while elimination is a great strategy, we do have to do a little bit of work in order to set up elimination to be a successful strategy to use. And the first thing we need to do is we need to rearrange both equations into what I call columns. And what this means is we just need to rewrite them so that they're set up in the same way and their x's, their y's, their equal signs, and their constant values are aligned. So essentially how I typically set these up is I do the x's plus the y's is equal to that constant that doesn't have a variable value. Now, you don't have to set them all up that particular way, but you do need to be consistent. The equal signs need to align the y's, the x's, and the constants. So if I set them up in this way with x's, y's, equal sign, constant value, I'm going to start by subtracting the 2y to the left-hand side of the equation. So essentially here I end up with 6x minus 2y is equal to 4. So notice that I have x, y, equal sign, constant. And if you want to use keep, change here, you're more than welcome to. Then from here in this second equation, I don't have to move anything to the other side of the equation. I just simply need to rearrange this, keeping plus signs with both the 3y and the 24x. So here I'm going to rewrite this as 24x plus 3y is equal to 60. So notice that these are now set up consistently. We have all of the x values first, the y values second, then I have my equal sign, and then I have my constant term. So we need to rearrange these into columns that align before we can even think about using elimination. Then at this point, we need to multiply each equation so that the coefficients of one of the variables can be added and eliminated. So again, we have to take another step to set up elimination so that it will be successful. If we just add the equations as is, we essentially end up with 30x plus 1y is equal to 64, and there's no variable eliminated. So elimination can't be used here because we're not actually eliminating a variable. So we need to set this up first in order to make elimination something that is successful. Now, it doesn't matter which variable you pick, you just need to pick a variable and commit to it. So here, I'm going to pick the variable of y. Then this next part here is kind of like finding a common denominator. We're going to focus on y, and our goal is to get these two y values to have the same coefficient, just with opposite signs, so that when they are added together, they will eliminate and become 0. So what I like to do is think about, okay, if I had a denominator of 2 and a denominator of 3, what would my goal be to get that denominator to as a common denominator? That would be 6. So my goal here is I need one of these two to have a coefficient of a positive 6 and one of them to have a negative 6. So that way when I add them together, they will become 0. So when I think about this first equation, in order to make it become 6, I would need to multiply negative 2 by 3. So what we can actually do is we can multiply through every number in that equation by 3. And as long as we multiply every number by 3, we aren't changing the integrity of the problem. It's just like multiplying both sides by a value of 3. Now, what I notice when I multiply this all the way through by 3 is I get 6x times 3 is 18x. Then 3 times a negative 2 is a negative 6y, is equal to 4 times 3, which is 12. So I can now see that my coefficient of y here is a negative 6. So I've taken care of that one. So my goal as I rewrite this second equation is to get this coefficient here of a positive 6. So in order to get 3 to be equal to a positive 6, I would need to multiply it by 2. So here again, as long as I multiply every value in that equation by 2, I'm not changing the integrity of the problem. It's just like multiplying both sides by 2, but I'm able to rewrite it in such a way where elimination will now be helpful. So 24x times 2 is 48x, plus 2 times 3y is 6y, is equal to 2 times 60, which is 120. So here I now notice that I have this set up where elimination will work. If I were to add those two equations together, the y's would eliminate. So now from here we can actually apply the elimination method. Remember, the elimination method, we add the two equations together with the goal of eliminating a variable. So we should see a variable completely eliminate here. So we're going to add these two equations together. 48x and 18x added together give us 66x, plus this becomes 0y is equal to, these added together are 132. So what I have here is I have the equation of 66x is equal to 132. And this I can easily solve in one step by dividing both sides by 66, and I find that my value for x is 2. Now remember here, when we're solving a system, we are ultimately trying to find a coordinate point where these two lines are intersecting. That is still what we are trying to find here. So my x value of my coordinate is 2, and now I actually need to find my corresponding y coordinate. So this is where the elimination strategy is just like substitution. We are going to take our x value and plug it back into one of our original equations. And it doesn't matter which one, just pick one of your original equations, substitute x back in, and find the corresponding y value. Now it doesn't matter which equation you pick. I'm going to pick the easier of the two with the smaller numbers. So here I have 6x is equal to 4 plus 2y. I'm just going to pick that one because the numbers are a little bit smaller. So now I'm going to take my x value and substitute it in here in place of x. So I have 6 times 2 is equal to 4 plus 2y. I then find 12 is equal to 4 plus 2y. Subtract 4 from each side. So I end up with 8 is equal to 2y, divide both sides by 2, and I find that my corresponding y value is equal to 4. Then I can take that value, plug it back into the other equation, and test that that is the correct combination of x is 2, y is 4, because this point will work in both equations. And then finally, I can write my answer as a coordinate point of x equals 2 and y equals 4. This point, 2, 4, is where the two lines at the beginning of the problem will intersect. So let's work through one more example together. So here I can see that I have a system of equations, and it's not quite set up ready for elimination, so I need to take those first couple steps and set it up using elimination. So my first step here is I want to rearrange these into columns. I notice that my first one is already set up as 6x plus 5y is equal to 19, so I'm going to leave it as is. Then I need to rearrange this second one here. So I notice that I already have 2x on the left-hand side, so I'm going to leave that as is. I then need to move this 5 to the other side of the equation. Now since it's a negative 5, I'm going to add 5 to each side, which would get me to 2x is equal to negative 3y plus 5. And then I need to move the 3y to the other side of the equation, so I'm going to add 3y. So I end up with 2x plus 3y is equal to 5. So I've now set these up into columns where the x's, the y's, the equal signs, and the constants all align. Then from here, I'm going to multiply as needed so the coefficients of one of the variables can be eliminated. Now remember, it doesn't matter which variable you eliminate as long as you are consistent. So this time around, I'm going to choose to eliminate x. So I'm going to focus on these here. Now again, remember, this is kind of like finding a common denominator. So when I look at 6 and 2, I know that a common denominator for 6 and 2 is 6. So what that's telling me is I need one of these coefficients to be positive 6 and one of these coefficients to be a negative 6. Now what I notice is that this first equation already has a coefficient of 6. So that one I'm going to leave as is, not change the equation at all, and rewrite it as 6 plus 5y is equal to 19. I am not going to change it. The second equation then, because I've already used up this positive 6, needs to have that coefficient of x become a negative 6. So I'm going to multiply this second equation through every item by negative 3. And by doing so, I'm not changing the integrity of the problem. I'm multiplying everything in there by a negative 3, so it's like I'm multiplying both sides of the equation by a negative 3. So here I have 2x times a negative 3, which is a negative 6x, plus negative 3 times 3 is a negative 9y, is equal to negative 3 times 5, which is a negative 15. So notice here that I've now rewritten this, so elimination is a great strategy to use. If we were to add both of these two equations together, we would eliminate those x values as they would become 0. So here, if I'll use the elimination strategy and eliminate, I end up with, if I add these together, I end up with 0x plus a negative 4y is equal to 4. So I here really have negative 4y is equal to 4. Divide both sides by negative 4, and I find that y is equal to negative 1. So I know that the y portion of my coordinate that makes both of these equations true and is where the point where they intersect is y is negative 1. Then I need to take one of those original equations and plug that y value back in so that I can find the corresponding x value. And again, it doesn't matter which equation you pick as long as you pick one equation because they're going to cross at that same point. So I'm just going to pick that second equation there. So I have negative 5 plus 2x is equal to negative 3 times a negative 1. So I really have negative 5 plus 2x is equal to negative 3 times negative 1 is 3. I then add the 5 to each side to start getting the x alone. So I have 2x is equal to 8. Divide both sides by 2, and x is equal to 4. So what this is telling me is that my two equations from up above will cross at the point x is 4, y is -1. And remember, if you wanted to double check, you could also plug this point into this equation. So if we do 6 times 4, that's 24, plus 5 times -1 is -5, and that does in fact equal 19. So we have in fact found the point that works in both equations. So now we're going to take our knowledge of elimination and apply it to a word problem. So let's just read through this together. It says a business has 2 locations and buys 7 larger delivery vans and 5 smaller delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000, while location B receives 2 large vans and 3 small vans for a total cost of $160,000. Essentially what we're trying to figure out is what is the cost of each van. So add that in there. What is the cost of each van? So before we even begin, let's identify what we are looking for and ultimately trying to find in this problem and assign them to variable values. So here, one thing we're trying to find is the cost of a large van. So I'm going to denote that as X. And then we have Y, which is the cost of a small van. So those are my 2 unknowns that I'm trying to find by the end of this problem. So what I'd like you to do is I want you to write 2 equations for the situation above, and you're going to write one for each company. So each company here actually has like a cost calculating equation that's going to be written in standard form. So with this particular problem, we're going to write 2 equations into standard form. And these standard form ones are really where elimination is a great strategy to use. So location A, what I see is that location A receives 5 large vans. So my equation for location A is going to be 5 times X. So I have 5 large vans times the cost of a large van plus 2 small vans times the cost of a small van, which is Y, is equal to $235,000. So that's how the cost is calculated for location A. 5 times the cost for a large van plus 2 times the cost for a small van is equal to $235,000. Then if I look at example B, or location B, we have 2 large vans times the cost of a large van plus 3 small vans times the cost of a small van is equal to $160,000. So here we can write one equation for each company. We have the equation for location A in red and the equation for location B in blue. So now here, because this is set up in standard form, elimination is a good strategy simply because it's already rearranged into columns. It's already kind of set up for us to be successful using elimination as long as we can get those coefficients to match. So here we need to pick a variable that we want to eliminate. And I'm going to pick Y. Doesn't matter which one you pick, I am just going to pick Y. Now remember, we need to think about, okay, what will that common coefficient be? It's like picking a common denominator, which in this case is going to be 6. So here I need one of these to be a positive 6 and one of these to be a negative 6. So I'm going to start by rewriting these, thinking through, okay, what would I need to multiply that first equation by in order to get the coefficient of Y to be 6 or negative 6. And what I see here is that if I were to multiply this first equation through by a positive 3, my coefficient of Y will become 6. So if I multiply through everything by 3, I end up with 15x plus 6y is equal to 235,000 times 3, which is 705,000. So now I've rewritten one equation and I've used up the positive 6. So now I need this second equation to have a coefficient of negative 6. So I'm going to multiply everything here by a negative 2 to make that 3y become a negative 6. So 2x times negative 2 is negative 4x, plus 3y times negative 2 is a negative 6y, is equal to 160,000 times a negative 2, which is a negative 320,000. So now I'm going to utilize the elimination strategy since it's set up for elimination by adding the two together. So 15x plus a negative 4x is 11x, plus 6y plus a negative 6y is 0y, so I'm not even going to write that in there for very long. And then I have 705,000 minus 320,000, which leaves us with 385,000. So really here I have 11x is equal to 385,000. And then if I divide that by 11, I find that x is equal to 35,000. Now we need to think about what x represents in the context of this problem, and x is the cost of a large van. So what this is telling me is that the cost of a large van is $35,000. So I've now found one piece of the puzzle. I know that a large van costs $35,000. So now what I'm going to do is I'm going to take this value and I'm going to substitute it back into one of these two equations. And it doesn't matter which one we pick, so I'm just going to pick the smaller one because it has some smaller numbers. So here, if I do my work over here, I have 2 times the cost of a large van, which is $35,000, plus 3y is equal to 160,000. So 2 times 35,000 is 70,000. If I then subtract 70,000 from each side, I end up with 3y is equal to 90,000. Divide both sides by 3, and I find that y is equal to 30,000. Which then if I think about that in the context of the problem, that represents the cost of a small van. So by using the elimination strategy for these two situations, I was able to find the cost of a large van is $35,000 and the cost of a small van is $30,000. So then from here in part 3, I want to apply this information to a new situation. So what would my total cost be if I purchased 11 large vans and 7 small vans? Well, we can just use the two values that we found concerning cost. So I would take 11 times 35,000 plus 7 times the 30,000 for a small van. So then if I calculate that using my calculator, 11 times 35,000 is 385,000 plus 7 times 30,000 is 210,000. So if we add those together, if I were to make those purchases of 11 large vans and 7 small vans, I would spend a total of $595,000 on my vehicles.